It did start with L. So that's a good guess. Uh, Now most of you guys take AP Euro. You should know who Descartes is, right? Anybody know who Descartes is besides the people who are not taking? Y'all are ignorant Americans. You grew up here.
Not really.
Not really. Okay. All right, Descartes. You guys gotta know who Descartes is. Elsa, do you know what Descartes is? Huh? What do you know about him?
Um, French Renaissance. Was he with John Locke and
Was that the guy who got
Lucas shaking his head. Lucas shaking his head.
what did the German dude?
Okay, let's ask you. What is Descartes' famous quote? You don't know? Lucas should know. What's the famous quote from Descartes? Ah, very good. Good. Okay. I think therefore I am. Okay. So Descartes at around 1600, right? Descartes um, is also like one of those people that who's um, very well known, not only mathematicians, also physicists, also astronomer. Or, they are pretty much everything. They are pretty much all the mathematician back then is like they are physicists, they are astronomer, they are everything. They are all around the people. They can invent stuff. Um, Descartes posed this problem called tangent line problem, and he wished that this is what it quote, and I dare to say this is not the only most useful and general problem in geometry that I know, but even that I ever desire to know. So he doesn't know how to solve the problem. Okay, the tangent line problem. So very well known problem in the world is a tangent line problem. Not until Isaac Newton says, okay, no, I can solve it. Okay, not until Limbus come out implicit derivative to help out Isaac Newton to actually like complete the work. And I do think like according to people tells me like Isaac Newton is um is um take a lot of Limbus work, and that's why he actually complete the work. It's actually how he invent calculus along the way. But he just gets most credit. But Limbus is one of them. So I think somebody told me how to spell them. I didn't know how to spell them. Uh, Leibniz. I think his last name is Gottfried. Gottfried Limbus. Uh, I don't know. I think it's German. I'm not sure. So somebody can look it up for me. I don't know what that is. Um, but he come out the work of implicit derivative, and really help out Newton now. So let's talk about what is the problem at very beginning. Now, first of all, do you guys know what a tangent line is? What do you know about tangent line? So Leibniz and Newton, right? They invented calculus. So don't take a calculus and don't know who invented calculus because math history is also important, right? Okay, so let's start with Descartes start with a tangent line problem. And who is why do they start with tangent line problem is because um I heard a side story. I don't know if it's true, but one of my good friend, his name is Mr. Jones. He teach in Cyprus, Craig. He teach BC, and he also teach in Valencia, teaching math history. And according to what I heard from him or his student tells me, he says that Isaac Newton is actually very religious. All Descartes, Isaac Newton, even though they are very like scientific person, but they are actually super religious. So I think he was observing the planet and he believed like the heavens over there or something like that. Well, this is what I heard from his student talk about it. I don't know if it's true, but somebody can correct me if I'm wrong. Um, then uh, he trying to find a heaven. He thought heaven somewhere on a space. Um, but he found out this planet is moving, whether it was Saturn or Pluto or whatever is moving. So he said, "Well, I was wondering how fast this planet is moving." Okay, so that becomes a tangent line problem. So think about it as a elliptical way, and if you ever want to find the speed of something, you actually had to find the slope at that particular point. Now we can find slope of a line easily, but the problem is this line is constantly changing, right? This slope is constantly changing. So that is the tangent line that we're talking about. So let's start with what is tangent line. The tangent line is basically inside in the geometry. This first time you were introduced about tangent line. The tangent line is a point that intersects only one exactly point. So it's like say this point and that intersect only one time there, and that's going to be a tangent line. So what does that mean? That means if I take this pencil and if I go in, like think about this as a function of the circle. If I touch here, that's gonna only touch exactly one point. And that one point is gonna tell me that's the tangent line. Also in geometry, you also learn this. This tangent line has a relationship with the center. Do you know what's a relationship? If I take this point of center, if you connect to this point of the tangent line, well, it's not radius. It is radius, but it's gonna form exactly 90 degrees. Exactly 90 degrees. So that's one of the first principle in the geometry that student need to get when we talk about inside the circle. Usually that part is very difficult, so a lot of students I don't even remember like half of the things there, but I remember the most important concept is the tangent line is gonna form exactly 90 degrees. Okay, so now we know tangent line. Do you guys know what a secant line is? Yes. Connect two points. Where do you learn that? In where? From my class or from where? Okay. Okay, so there are 2 points. That's called a, if we connect 2 points, that's called a secant line. So we have to understand the idea of a secant line and tangent line. If you want to understand the idea of secant line and tangent line, then we can start talking about the tangent line problem. So now inside a graph, what does a tangent line look like? So let's just say if I have a parabola, right? If today I have a parabola, and this point is going to be here. And so let's say if I want to find out the tangent line here, the tangent line is going to be like this. Okay, the tangent line at this point is going to look like this. Okay, the tangent line at this point is going to be like this. So this is our tangent line. Now, we're going to start by looking at the tangent line and secant line. Now, secant line is going to go through like 2 points. And that's that. So we're going to start by drawing what we need. So let's just say, for example, this is probably the only graph that you need to understand. And you might need to color code this because it might help you. So let's just say if I have something like this. And I just say if I want to find out this tangent line at this point. Okay, so this is a tangent line. This is our goal, to find the slope, right? We're gonna find out what is what is the slope. What is the slope? Now what I'm gonna do is I'm gonna start with the secant line first. So I'm gonna draw this line continuous going up. So we're gonna pick a point here somewhere down the row, and we're gonna pick this point, the black line here, and black point here. And each point I'm gonna name a coordinate. So first of all, I would like to name this function as f of x. The first coordinate here, we're gonna call that, we're gonna start calling by this point is gonna be f of x, no x, sorry, x comma f of x. Is that okay? That's just the first point here. Now I'm gonna go from here to here. We're gonna say this is some type of h. H is arbitrary. In this case, is roughly 4 point something, but I can go a little, it's 4 point something. So this is h. But I don't care about how far is h. We know h is some type of small value. It's not something very big. It could be like 0.2 or 0.4 or 0.5. It doesn't really matter. It's arbitrary. Now here's the thing. What will be the name of this new coordinates? If the bottom part is h. Hold on a second. I call on other people. I think they don't know. I want other people to think about it too. What will be the new coordinate of the black dot on the top? Nina? Almost. Ashton? Yep. X plus h, comma of fx plus h. Why? Because basically if this one is, let's just say it's a 1 and this is a 2, and here it's going to be 1 plus 2, right? And this one's going to be the input of fx plus h. Now what we're going to do is we're going to create this black line. Our goal is to from a black line turn into the red line. So so the black line is right here. It's called secant line. Is that okay? So now we want to find the slope of the secant line. So let's find, sorry. Let's find slope of secant line. What will be the slope in this case? We also know as m. M's represent slope. What will be the slope in this case? How do I find the slope? EM, pay attention. You pay attention there. Is algebra 1. y2 minus y1 over x2 minus x1. Well, what? You're right. Okay, so y2 minus y1 over x2 minus x1. So what will be the slope in terms of new coordinate? This is a y2, and this is a y1, right? And this is a x2, and this is a x1, right? So what's y2? F of x plus h minus f of x over x plus h minus x, right? Can I simplify it down to f of x plus h minus f of x over h. So that becomes the slope of the black line. Now the thing is, I don't care about black line. I care about the red line. The red line is the h. Somehow, if I change that h, I start shrinking that h. H is right here. It's gonna form a slope of black line. What if I shrink the h to the new h to, let's just say I'm gonna use purple here. Let's say new h is right here. So this line of this line is gonna create a new secant line. So h is went to like say new prime, the new h, shrinking the h slowly, right? And your idea is shrink it even slowly. Go to here, and I'm going from this point to this point. I'm going to connect a new point. But the thing is, I'm still connect 2 points. It's still a secant. The black line is a secant. The purple line is a secant. The purple line, the new purple line is secant. But your idea is to make that purple line gets closer to the red line. That means I'm shrinking the h to as minimum as I can. So I'm gonna try one more. So that's gonna be a new h here. But ideas, you're still gonna intersect 2 points here, very vaguely, but it still intersect 2 points. So went from black, purple, 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 all the way to red. Basically, I'm just shrinking the h this way. H is gonna go to a what? H is going to what? Equal to 0. You want an h approaching 0. So therefore, what's the only limitation? There's only a math notation can help you to do that. What we just learned on the last test. Limits. So let's say limits. Now I'm gonna say m of a tangent line, which is slope of a tangent line, is basically adding the h approach 0 of f of x plus h minus f of x over h. Now this is the slope of tangent line problem. Newton used simple algebra 1 to solve this problem by assigning a variable on h and hoping that h is going to go decreasing to 0. If you do that, it's going to be better. So now let me show you what happened here. So if I go to Desmos, and actually if you click here down here, all the way on the bottom, there is a calculus secant line right here. So imagine that if I'm trying to find this dark circle, the dark circle slope, I can start by shrinking the h. Do you see that h is going to start at 2? See here? And you also see the next line is a slope. The slope is 0.233. Now h is going to start decreasing. So let's say h is going to change to, let's say, 1.5, right? 1.5. Do you see that h went from here to here, right? And go to 1.3, 1.1, 0.9, 0.8, 0.33, 0.6. It's almost equal to that tangent line over there. But what happens if they approach 0 though? There's a problem. If they approach 0, it's not defined anymore. So you can get somewhere that's very, very close using limits. So let's just say 0, 0, 0, 1. That's going to be pretty accurate. The slope is going to be 1.096. Now here's a slight issue. Some people says, wait, Mr. Ye, that looks like a secant line to me because it intersects 2 points. But the thing is, we only look at that small region because the line curve back, they are always going to have that second point. But we only look at the specific region right here. Do you see that? That's exactly the tangent line. We don't care about what happened and somewhere down later they will touch each other. We only care at that special region over there. Does that make sense? So now we're going to call that this is a derivative of something. And derivative, we're going to use in this new notation, is called f prime of x. F prime of x equal to limits as h approach 0 of f of x plus h minus f of x over h. Is that okay? So this is a slope at any given point. It's a new function. This function called f prime of x. That means the derivative of the original functions. This can provide a slope at any given x. Now I'm going to show you an easy example. Let's just say start with this, f of x equal to x squared. So we have an x squared graph. We say, okay, I want to take a derivative of this function. Not only I want to take a derivative, I want to find out the slope at any given point. So first of all, I say the goal is to find f prime of x. The second goal I want to find is I want to find equation tangent line. And third, I want you to find equation of normal line. So first, let's find out what is the derivative of f of x, which is known as f prime of x. That's how you're going to say it. F prime of x is going to represent slope at any given point. So we know f prime of x is going to be limits h approach 0 of f of x plus h minus f of x over h. So what does fx plus h mean? That means a long time in algebra, you learned this. F of x equal to x squared plus 1. Well, f of 1, that just means replace the x with 1, right? Does that make sense? And that's going to be 2. Now, what if f of x plus 1? That just means what? X plus 1 squared plus 1. Does that make sense? I just replace the x with the x plus 1. Whatever inside the parenthesis, you replace in that variable with that whatever inside the parenthesis. Does that make sense? So what would it be here, though? We replace the x with what? What is it? No. We replace the x plus h to where? To the functions, right? So what would it be? Limits as h approach 0 will be what? X plus h squared. Does that make sense? Minus f of x. We already know f of x here. So this is some other example. Don't worry about it. This is just something that we worry about right now. This one's going to be x squared over h. Is that okay? Now, please don't tell me that x plus h squared is x squared plus h squared. If you do that, you kill a puppy. So limits as h approach 0. This one's going to be x squared plus 2hx. You guys know how to expand, right? Minus x squared all over h. And then you're going to cancel this. Why? Because this is x squared and x squared. So that's equal to limits as h approach 0 of 2hx plus h squared over h. Now here's a problem. The problem is h on denominator. Ian, are you paying attention? You're looking away, so I don't know if you pay attention. The thing is, the h on denominator goes 0. If it goes 0, it's either indeterminate or undefined. What can I do here? How do I get rid of that h? Yes. Yep. So it'll be 2x plus h over h, right? Now can this cancel out? And what else I can do? Besides cancel out, I still have h. What does h goes to? 0. So guess what? 2x. 2x is equal to f prime of x. F prime of x. The cool thing about this is it tells you slope at any moment, not only at one specific point. It actually gives you expression of the slope at any given moment. At any given x value, it can be done. So what I'm trying to say is, okay, well, let's find the equation tangent line. But I need to give you an x value. So choose the x value you want. Can you choose a value for me? 4. Good. So if I pick 4 here, I want to find the equation line, tangent line at x equal to 4. But the first thing I need to find out is not only the slope. I need to find out if x equal to 4, what is my y value in the function? If x equal to 4, what is the y value? Y is 16. Yeah, because f of x is equal to x squared, right? Well, what's f of 4? Which is 4 squared, that's 16. Which is, that means there's a coordinate 4 and 16. But the equation tangent line, I need the point. What else I need? What else I need? No, not h. Slope. Yes, I need to find the slope. How do I find the slope? The slope is coming from f prime of x, right? We know it's 2x. So can we find the slope? Which is what? Plug in 4. So it'll be 2 times 4 is equal to 8. Is that okay? So now I'm going to tell you, a lot of you guys like use y equal to mx plus b. I'm going to tell you from now on, do not use y equal to mx plus b. You use y minus y1 equal to m times x minus x1. This is a better formula because on AP exam, you can literally just plug in this coordinate. Y minus 16 is equal to 8 times x minus 4. And then equation tangent line, you're done. You don't have to do any work. Because you can plug in a point and plug in a slope. Now, some people use y equal to mx plus b. There's a problem with that. Because sometimes if you evaluate a b wrong, let's just say, in this case, b, you got a 15 rather than 16. Then you're actually going to get the answer wrong. But if you plug in here, it's no brainer. You just have to plug in a point and plug in a slope. You don't have to do any further. If you want to get the y equal to mx plus b, just distribute. Y minus 16 equal to ax minus 32. And y is equal to ax minus 16. Now, if you do your calculation wrong, you happen to get 15 over there rather than 16. The grader will give you a point just based on here. So you don't have to do any math. You don't have to solve for b. So don't get used to y equal to mx plus b. That's actually a bad format. The point slope form is much better format than this. And if I want to find the equation normal line, it's even easier. By the way, those of you guys take physics, do you know what's normal mean? Anybody taking physics right now? What does normal mean? No clue. Andrew's gonna blame on the teacher.
Teacher.
He's a good guy. He's a good guy.
Is the largest in x minus 16?
Yeah, y is a expenses. But like I said, use this format. It's fine. Just y minus 16 equal to ax, a parentheses x minus 4. So when it's talking about normal, that means the perpendicular. You might want to know that. And also in physics, we also call it orthogonal. Orthogonal is also means perpendicular. But in the Calc 3, you're going to talk about orthogonal a little bit more rather than Calc 1. So right now, we're just going to use normal. Since normal is perpendicular, can I just say y minus 16 equal to negative 1 over 8 times x minus 4. Do you know why it's negative 1 over 8? Yeah, perpendicular, so it's opposite reciprocal. So right now I want you to figure out this thing. Y equal to f of x equal to square root of x. I want you to figure out, find f prime of x first. And the b, I want you to find equation tangent line. At x equal to 4. C, normal line at x equal to 4. So your goal is to find out what's f prime of x here if I have f of x equal to square root of x. Today's work is going to be a lot of algebra. You're going to have to figure out your way about algebra. Yes.
So I guess I take a shot at f prime. Might know. I think.
What'd you say?
My answer A.
No, because I don't want you to do it with the power rule. I want you to do it definition of derivative because I know Anthony probably teach you already how to do power rule, which is the goal is not to use power rule. The goal is actually understand how to do definition of derivative. And this is also a good review for the last section on the last test. Okay, since the time is almost up, f prime of x is equal to limit as h approach 0 of x plus h minus square root of x over h. Now, so in the last section that you know is conjugate, this is going to be 0 over 0. So this is indeterminate form. So this is a conjugate. And if you do conjugate, then you will have limit h approach 0. You can go if you want, but you guys should know how to do this. And you can watch the video. This x and x cancel out. H cancel out is 1. So if you plug in 0 here, it's going to be 1 over 2 root x. If you did that, you did great. Now, I want to figure out what f4 is. f4 is equal to 2. And f prime of 4, I'm going to plug in this 2 square root x, which is 1 over 2 root 4. So it'll be 1 over 4. So it'll be y minus 2 equal to 1 over 4 times x minus 4. I find the equation tangent line. Also, y minus 2 equal to negative 4x minus 4. That's the equation of normal line. And Emerson, do you know why I look at your test and I know you're not prepared? Because you didn't know how to do conjugate. And that doesn't mean that all the homework you show me, that you did conjugate, but you did not translate on the test. That means the homework you just come up for no reason. Otherwise, you will understand how to do something.
How did you conjugate?
Nope. I told you guys when it's radical, you gotta do a conjugate. You didn't even show me the step of conjugate.
Yeah.
And then he like